welcome to this session. Yeah, let's just start having some fun together. Today we are going to look at the layering of implementation guides and how that works. So we are going to run through a couple of topics. So let me just start sharing my screen. That might be the best thing. Second. I presume you can see my screen.
Yep, good to go.
So let me share this. Yeah, so today we are going to look at very briefly at how this fits into the whole scene of our webinar. So where are we in our kind of work? So a very quick recap of where FHIR stands as a standard. So we will look into that just to explain a bit the context, and then we'll look at this in two perspectives and then do something about it. So the two perspectives, we'll see how do we structure an implementation guide inside, so how it is structured inside, although you have seen it, it's just a bit more of formality to this, so that we see what is the content structure of an implementation guide and how can those be structured. There's at least two different approaches to that. We have to choose the best of both worlds, I guess, or whatever is more functional to you, depending on the type of implementation guides that you are looking into. We'll look at some examples of that to see how the implementation guide gets structured in content. And from there, we'll see how can you use that structure of content to have it over different layers. So we'll see what FHIR implementation guides have that allow it to be structured and layered. Then we see how do we make multi-layer specifications based on that. And the third part, the most interesting one, is the hands-on. So we'll see what we can make up as a goal. So it's just going to be a simple scenario just to see how things can work. So we'll have a bit of hands-on. So nothing terribly complicated, just to show the same things that we discussed in theory, let's say, being applied in practice. And then some Q&A where you can please bring up your context, your challenges, your ideas. It will be really interesting in the session to see what you're up to and how do you feel this being applicable to you or not. Are you going to make, so some of you might have questions like, does this mean that I have to make my national implementation guide before I do my project implementation guide? To which my answer would be, yes, you should, unless you really, really don't think you will ever have more than one project. So this kind of discussions will be interesting to have today after we see how these things work. So it's not going to be a heavy content, just some guidelines for us to navigate the whole layering of implementation guides and how to do it in practice. With that, and presuming we are ready, let me see if I can open my, oh, I forgot to commit these changes. I just did no, I did commit my changes. So let me just open my editor just in case we need to do some coding in the second part. The house rules. Throughout these presentations, we talk about FHIR implementation guides. So FHIR is a registered trademark of HL7. The fact that we are running these webinars, it doesn't mean that we are either endorsing only FHIR or any specific way of doing FHIR. And most importantly, it doesn't mean that this is endorsed by HL7. This is just we are applying that standard and the knowledge that we have built over time around it. This is not an official HL7 training. So if you want to have such formal official trainings, then you can go always to hl7.org/training. And this presentation is a collection of freely available materials. So we share with you and with everyone openly under a Creative Commons attribution license, which means we take from others, and we expect things to be taken from us in the same approach, which is just please adapt and credit or credit when you adapt things. So yeah, as I said before, how FHIR specifications are structured on the inside, how we use that to allow inheritance and to make inherited and layered implementation guide or specifications, and then a bit of a hands-on. So now the first recap of very brief recap of where we are at with standards, or how do we work with standards. If you remember, I think this was already in the first session. When we want to do standardization, there is always a reason for that, and that reason is I want to be conformant with standard X. That's normally an imposed standard. Typically, ISO standards, they are imposed because they are legal standards. Or we want to support internationalization, so it's a more of a mercantile, I would say, approach requirement that we really want to sell our product outside, or we want to import something that is working well outside, but we have to adapt it here. So supporting internationalization really depends on standards, because if you have to reinvent the wheel every time that you deploy a product in a different country, then you're having a lot of work. Other motivation for standardization is that you want to be compatible with another solution that's out there, and hopefully that solution adheres with standards. We also want to standardize the data so that when we do analytics, that the data somehow makes sense, that if what we call patient in one side, in one system, which is everyone that ever visits the hospital, at least once has a unique identity. And in the other systems, in the other system we say, well, patient is anyone that enters the hospital, and if they enter twice, they count as 2 patients. So, okay, then you know that your reports will never be very accurate. So if we want to standardize our data, then we look at standards as well. And very interestingly, we want to reduce complexity while supporting variety. This goes to the heart of what we are discussing today. We want to support different use cases. In one country, we might have one use case. In another project, we might have another set of use cases. That variety is expected. In some places, some data elements are mandatory, others are not. And we want to do that, but while reducing the complexity of that mesh of specifications, that it can really get very dense very quickly. So we want to support standardization also as an effort to somehow reduce that complexity. And this is what we are going to discuss today. Also, still just to position things, HL7 is on the OSI model, is on the application layer. So it describes what applications say to each other. It's not about the transport of information, although it has a bit of transport, but on an application layer, application level. So just it's on a relatively high level. It's not really it's not like SMS or lower level standards or IP standards. It's a higher level. And looking at the Zachman framework, when we talk about HL7, we are talking about data entity specifications. So we are defining the data, that's the interface, but we are also kind of defining the data models, the process diagrams, like what happens when. So we are looking at defining things around the data, but also how the data is used. And those things, they need layers. In the sense that if you do something for one project, I have a diagram here. Yeah, let me get to this first. If you want to do a specification, maybe there's a data model that you already can reuse. Maybe, well, the fact that we are using FHIR as a basis and then building on top of that, then we are layering already things. But if there's an OpenHIE guidance or an IHE profile, well, if we can do that and save the work of maintaining that specification so that we just reuse it, the better. So the goal of today is to see how in practice those layers get to be built. And now I'm going back one slide. This is the FHIR standard, just a representation for the simple representation of what HL7 FHIR has. In its core, it's the information data models. We have resources that have elements and that have data types. So some elements, all the elements have data types, and some elements have terminology binding. So some things are coded, and that includes value set and code systems. So we have discussed these things in previous webinars. This is pretty much the core of FHIR. So defining the data needs and the technical data needs. FHIR also addresses things like, how do we access data? Is it through an operation, or how do we interact with systems? Is it operations? We have resources. How do we do search, etc.? And then also the transport mechanisms like REST, GraphQL, messages, documents, different ways of accessing the data. Also, how do we do data models? How do we do mapping between the different data objects? And there's a bit of implementation support, which is about the implementation guides and how do we test FHIR specifications, etc. So we have these building blocks that we can use on FHIR. And today we are going to see how we put these in a layered structure. Let me just, so first a reminder. If you haven't seen the webinar on FHIR profiling, I think that was the second webinar, so it should be around May 2021. If you haven't seen it, you should. But very shortly, it's very important to keep in mind that FHIR profiling consists of creating resource instances. So when we do FHIR specification, we say, I'm going to create a FHIR structure. I'm going to create a specification for a data object, so in FHIR we call that a structure definition. I'm going to create a value set. Well, okay, we call that a value set. I'm going to create an example, and so we are creating mostly FHIR resource instances, so FHIR resources that define a specification. So structure definition, operation definition, search parameter, even example instances. Those are the things that we are doing when we build a FHIR specification. On top of that, or next to that, we also build narrative. Narrative as just descriptive text, and we can put everything we want in the text, diagrams, we can put pictures, but the resource instances, they are structured and they are computable specifications. That is really important. So this is the thing that supports inheritance. You will see all of this, I'll show all of this in practice, but the fact that I created a structure definition in a national level, for example, I can reuse that structure definition in a project because it's computable, and so the computer can see, I want to inherit this, so I know exactly how to interpret this structure, and then I add the following constraints. And FHIR profiling, that's the thing that we are doing, it goes into constraints. So when we say, I want to take the national specification and further profile it for my purpose, the only things I can do there is to make it more specific to my specifications. Let me give an example. If the patient name is mandatory on the national specification, we can no longer make it optional on a project specification if we want to use that as a layer. So if I say I'm based on that national specification that says that the patient name is mandatory, from that moment on, it is mandatory and it will be mandatory. The only thing I can do is to say it's mandatory, but I'll put a dummy value if I don't have it. But if it's mandatory in the lower level, in the lower layer, then it has to be mandatory in the upper level, which is an attention point that I will recall in a few minutes. We should not over-constrain on reusable specifications, meaning that if I go back here, if I make my national constraints, my national guidance and my standard constraints like OpenHIE, IHE, if they are very strict, then this means that the layer above has to be even more strict, and that's something that we don't want, or might not want, because it might harm the inheritability of the specifications. I hope this is somehow making sense. I hope it will be clear when we go into examples. But all of these are things that we discussed in the profiling webinars. So with this, going a bit into the FHIR implementation guide structure and how we standardize and layer this thing. How are they structured? Different ways of doing that. The first example is that we structured information implementation guide in knowledge level. So I'm just going to open this. Oh wait, I cannot open this apparently, because maybe I got the URL wrong. Yep, I did. So here's an example of an implementation guide. It's an HL7 issued implementation guide, and that it describes its own approach. So this implementation guide describes the approach for making that implementation guide and says that these are the levels of structuring the implementation guide. We have level 1, aka narrative knowledge representation, or we have semi-structured knowledge, or we have structured knowledge or executable knowledge. There is an overall description of what this means here, and I have it in the slides as well. But what it comes down to is that in the level 1, for example, you say, you have the guidelines for prescribing opioids, or guidelines for antenatal care. So these are typically PDFs published by some organization, and they are not computable. They are just clinical expressions of what should happen. So that's a very it's a human readable, but it's not a computable set of behaviors and requirements. That's level 1. So it typically includes what is the focus about, what's the scope, what settings is this going to be used in, what recommendations are in there, what's included, excluded. So these are things that we humans can read and understand what should happen in practice. Then we go into the other levels. So then we make it more and more computable, more and more structured. So very shortly, level 2 is when we start structuring things, when we put some business process around these things, some diagrams to say, okay, this still requires a person to read it, but the person now has a much more solid structure. So we have user stories. Typically, the user stories are always in the same place. We know where to get them. So we have workflow diagrams. We have personas that we can reuse across specifications. So this is structured in the sense that information is there, but it's now kind of templated. And this is semi-structured, so it has already some structure. Level 3 is convened into this structuring to be the computable representation. So this is the thing that computers can understand. So this is when we are talking about computable models, rule sets, data object definitions like structure definitions in FHIR. So this is when we have the things that the computer can understand, and those are the ones that we are going to inherit, to use for inheritance. And the level 4 is an executable implementation of that. So it's no longer the specification, but it's actually something that is working on the system working. So when in an implementation guide, we go all the way down to level 3 and say, this is what needs to happen. These are the data structure definitions so that the computer can use this to validate. These are the value sets formally and computably defined so that the computer systems can see if an incoming message is actually according to that value set and to that data structure. So we have the level 3, and then level 4 is the actual implementation of that. So typically outside of implementation guide, unless the implementation guide describes what the specific software is about. So that would be pretty much, let me just show you the top of this pyramid there. Nothing prevents you from having one implementation guide for a specific project. If the project makes it relevant, then you, or if for a specific application even, you can do that. If you say this application declares that it follows the following specifications, and then you can choose, do I follow the national guidance as a general, or we say, no, we have to tweak things and we have to make some constraints. So this project also publishes its own implementation guide. Nothing prevents, and I think it actually is not a bad idea to prepare for that. So Irene, if I'm pronouncing your name correctly, asking, is it okay to have something mandatory in the higher level? It's not mandatory in the lower levels. Irene, I do not know if you mean higher level in this sense of the pyramid, so I assume so. I would assume so. If you have something mandatory on the project specifications that is not mandatory on the lower levels, yes, that is okay, and that is actually the normal situation. So if you want to make it mandatory, try to make it where you really need it. Yeah. So if you can make, for example, here the patient name in my project. Let's say my project is a fitness application, fitness tracking application, or physical exercise tracking application. In that case, I want the device ID to be mandatory. But the national guidance doesn't say this, because the national guidance says it can be the patient entering this by hand, so there is no device capturing the information. So it's perfectly legitimate that for your project or for your scope, you say the device identification is mandatory, but in the national guidance, it's not mandatory. So that's what's intended. The other way around, that would be tricky, because if you see the national guidance says that the device ID must be there, then by doing this, you are preventing anyone from ever doing a paper-based reporting, because they would need to fill in the device ID, and this doesn't exist in a paper submitted form. So that was the intent. So Yeah, so this is one way of structuring things. So where we have the implementation guide looking at starting with the PDF that is, for example, guidelines for treatment or prevention of some disease, and then we get some structure behind it. We make some diagrams, we make some decision trees, etc. And then it's human readable but structured. And then the level 3 is where the computers can actually take this because everything becomes computable. This is one way of splitting the data. Another thing is to split it as you would normally expect from a more architectural perspective. And here's one example, here's another example. I'll go through those both. They actually mean the same thing. So if you can structure implementation guides as in different ways. So you can say, well, I'm going to put the vocabulary on one side, and in the vocabulary I put all my naming systems, my code systems, my concept mappings, and my value sets. Let's assume that this is what was intended to be published. And then I can structure my implementation guide by having the functional module different from the technical specification. For example, in the functional module, I describe the use cases that I expect to be necessary, and the business services, in the sense business service could be, for example, handle prescriptions, or capture vaccination events, or capture adverse drug events. So this would be a business service. Logical models, logical data model that comes with it. So those are functional or business language descriptions of something that you want to specify. So use case, business service, logical model, and they can be captured. So this would correspond between the level 2 and the level 3 of the other approach, but you can capture those in one, let's say in one section, and then in another section you do the technical implementation of this, where you go to all your search parameters, your profiles, your example scenarios, your actors and transactions, your operation definitions. So that's actually the technical implementation of this, and then the support, where you add your test data, your test scripts, and your capability statements if you have to use those. So you can structure implementation guides like this, and I'm just going to show another example. This one is from IHE. I think it's actually clearer, gives a better representation of what we are talking about. Although some things here are still a bit fuzzy. But for example, IHE organizes its content into a few sections. Typically, volume 1, which is a functional description of what we want to do. And then we talk about, there's a bit of an introduction, and then some actors, some transactions, some actor options, some use cases, some security considerations, and grouping behavior. So how do you group those actors? That is pretty much on a functional level. So you say, for example, the document consumer is associated with the audit log. I don't know the actor, but audit log reporter. I don't know the name of the actor by heart. But this means that whenever you consume a document, you also have to do the audit logs. That's easy to describe functionally, and that's what it comes down to. You describe the functional building blocks that you have when you define the volume, so the functional perspective. On a more technical perspective, you actually decide what is the behavior that we want to have. For example, the different transactions. So store multimedia report. This is from an implementation guide from radiology. So from IHE. Store multimedia report, display multimedia report, find the multimedia report. So those are the different transactions. Those are the different types of data exchange that we want to standardize. So in volume 2, we go into decomposing the use cases and the actors and transactions and defining them in a way that it's technically unambiguous and clear. IHE also separates the volume 2 transactions, which is how the behavior is expected to be, from the volume 3, which is standard content. So if throughout these things, if you have standard value sets, for example, then you would put those into the volume 3 content. So you separate things like volume 1, pretty much for a business user to read or a clinical user. Volume 2 is for an implementer. Volume 3 is also for an implementer, but volume 2 is more focused on the dynamic behavior. Volume 3 is more about the content and the value sets that are implicit in that are required for making those transactions work. Then there's volume 4, which is national extensions. We don't cover that. So this picture doesn't cover that, but that's actually what we are going to do. But it's basically the same thing. So this is the basis, and then on a country you can have. Sorry, the picture is covering this here. You can do the same content, but for a country, you might want to have additional constraints or additional extensions. That's pretty much just the layering that we're talking about. And then the artifacts that we have, it's those technical FHIR artifacts. So the concept map, the value sets, the capability statements, etc. All those, they can be grouped together, although I think eventually they will end up in volume 2, or maybe not. And then the testing is just another way of structuring. So test data, cucumber, scripts, example scenarios, etc. So these are ways to structure this. So, and I'm very sorry to have bothered you with the theory behind this. So here, just for good measure, here's another, and this is the final one, I promise. Well, not the final diagram, but the final one before we go into more fun stuff, into how to do things. So just taking that, here's one representation of what we are talking about and linking this to the FHIR thing. So we have use cases. Use cases, they use transactions, and transactions, so exchange of data between two parties, they adhere to data specifications. So like if I say, send the prescription over there, I can say, well, then the prescribed service or product has to have a code, the patient has to be identified. So those are the data specifications. So these are structured objects. So if I can structure my use cases, and if I can structure my transactions, and if I can structure my data specifications, so that's the form, the functional layer of this. And if I define also my vocabulary, so if I have, so data specifications is just a collection of data elements, and if in my data elements I can have value sets or code, which are obtaining codes from code systems. So if I start organizing these things and say this is the functional bit, this right side is the terminology bit, and then if I say the use case, well, I can make an example scenario resource. So these are FHIR resources here on the lower level that I can define, and then the operation definitions or profiles, and the profile implements a logical data model, and the profile also contains the element definitions, and the profile can be seen in a data capability statement and can be used in an example instance, and the search parameter is also there in the picture as part of the capability statement. So these are very basic set of blocks that we can define in a structured way. And next to all this, there is narrative text. So, and if I have this, and you see from this diagram that, let's say, these are formal data objects, so formal artifacts that we have. If I can do this, then I can do the next thing, which is, can I reuse them? And that's what we are going to look into. So we are going to see how do we take a FHIR implementation guide and allow it to be reused in the next level. So let's say we have a guidance. Going back to our example, we have a guidance on food allergy, and that's generic guidance. We don't care about country A or country B. It's generic guidance, basic guidance for food allergy. And in that guidance, we were not over-constraining because we wanted to keep it as generic as possible. But now we want to prepare that, or we want to enable that package to be used in a country, to be further constrained for specific country requirements. That's what we're going to see today. And this picture is about, with these data objects, we can have layers of these. I have a picture further ahead, but one important thing is more for the technical implementation of this, and also as a constraint. So if you have, this picture. If my implementation guide has use cases and transactions and data specifications, if it has all of this, then I put it in a package, and that's the package that I'm going to inherit. So for example, I can say this is the case reporting package, or this is the HIV case reporting package, or this is my country's HIV case reporting package. Those are packaged together. So all of these come together when we use a specification. And it's just a natural consequence that if you make your package too big, then you are inheriting a lot of stuff, lots of baggage. I think you have to find a good balance between, do we really want to have one big implementation guide that contains everything for one country, or do we want to have, for one country, we want to have one implementation guide for the medication part, and another one for the lab part, another one for the radiology part, or another one just for the terminologies, or just another one for the abstract terminology, and the other one for the actual implementable terminology aspects, or one just for the blue stuff there, the use cases and transactions and data specifications, and the other one for the technical part. Those are all decisions that you will need to make. The important thing is that once you do that, then the package standalone can be used to be inherited. normally my recommendation would be not slicing, so not taking any box out of this if you can use it. So if you make something about HIV case reporting, then I would try to say, if it's okay if I don't have an example scenario, but if I have a logical model, I should not separate the logical model from the profiles, because if the profile implements the logical model, and if I change my logical model, then I must make sure that my profile is still respecting those data specifications in the logical model. So I would try to keep these things together. So not making an implementation guide that contains a bit of each, and not one implementation guide that takes, for example, all the use cases for the entire country, or one implementation guide that contains everything about medication and lab and radiology and referrals. Because that would be way too big. So that's one of the conclusions. So choose the right size when you make the packages. It will be clear more clear, I hope, when we go through the exercise. And yeah, so each implementation guide has its own package. So we choose the right size for it by not making it too big that it becomes very big. Yeah, just huge package. Or not too small that then we are always making a Frankenstein of things that may or may not be consistent. And another important thing, just repeating what I had said before, with an implementation guide, we get the packages as they are. So when we inherit the national specification, we get the national specification as it was published by our national authority. So if I'm working on a project, I don't have the power to go and change my national specification. So it's really important to find the right balance for constraining in the right level, meaning that if something is mandatory on the national level, then it becomes required for everyone that wants to adhere to that specification, which in practice doesn't mean that we are over limiting. It means that developers will simply ignore our specifications. If you make it too strict, like everything in life, if you make it too strict, then people at some point, they will just say, well, I would love to use this, but this is too strict, so I'll just start something aside. So try to keep the right balance, make it very flexible, very liberal in the lower levels, and go more specific and more constrained and strict on the upper levels, so on the project level. Right, I don't know where we are on time. I think we are good to start we are good to start the hands-on. Before I continue, at any time, please feel to interrupt. Let me have questions in the chat. Tell me if this makes sense. If it doesn't make a lot of sense, speak up, or just give it a few more minutes until we go into the practical example of this to see if it makes more sense. But from now on, please interrupt. I'm going to have some interaction with the system to show how this works and show how we can make a simple inheritance example here. So let's do this. Let's make our own food allergy specification. So from our previous webinars, we made a very simple dummy implementation guide that was talking about food allergies. And those food allergies, we said, well, we want to have something. Let me just show this to you, what we had. Let me see if I can show this to you. This should be it. Of course not. This is it. So we had a food allergy, and just as a quick reminder, we have in our table of contents, what we did was just make a small introduction to see what is food allergies about. So we did it a very, very simple thing, just to show the narrative. So this is the narrative part. We also have a couple of resources, and they were, we had the data model, and so we had the data model for the food allergies. So that's the data that we expect to have in a food allergy report. We also had a questionnaire. We added later, but I'm going to skip that. We had the food allergy profile. So just open this, and the value set of food allergies and the example. So let me just share with you. So this is the profile that we have. This is the FHIR profile. I'm not going through this in detail right now. Just in a few minutes I will. The food allergies, this is the value set that we have defined. at the time, and this is an example. So first of all, this is the thing that maps to this picture. So in this picture, we have data specification. We have our data models. So this part here, we had a profile, and we had an example instance, and we had the value set. That's what we had. And of course, the element definitions were part of the data specifications and of the profile. So we had 1, 2, 3, 4 instances that are relevant for our scope now. So that's what we had. We defined those, and we said this is the generic implementation guide for food allergy. The source is there; it's available. So we did and as a recap for those who were not there, so we said, well, what do we want with the food allergy? Let's ask the clinical people, and we imagined that after some iterations, we got this here. We had some interaction, and we had some ideas like, okay, we should have a patient, which should be a reference somehow. We have allergen, which should be coded. We have a clinical status, which should be coded, and we have verification status, which should be coded, and it's mandatory. So we had these ideas from the clinical people. So we documented this. We made an implementation guide. So today, what I wanted to share is how do we take that and say, I have something to add on top of this. I will first see if this is okay for me. So if all the things that are mandatory, if I can still make them mandatory. If not, I stop there. I cannot use the model or I cannot reuse the model if it's not compatible with my expectations. If I cannot constrain it further, especially the profile. The model is different, but the profile. So the profile says the clinical status is mandatory. If my requirements say that clinical status is not mandatory, then we stop there. We cannot inherit it, and that's something that we are going to see. So yeah, we have this this content published, and this is published as an implementation guide, so it's out there. There is a package out there published somewhere in the FHIR repositories. So that's what we have. Let me go back to the picture. And suppose for our exercise now, we are going to see this as. So the example, the goal today is to see, I want to have the same food allergy there, reusing as much as possible, because I don't want to bother maintaining those specifications if I can just reuse them. But I think for my country, that food allergy misses a couple of things. And the first thing it misses is that I don't see allergy to wheat here. And I think allergy to wheat is important. It's part of the things that I have to report in my country. And that's what we are going to do today. So we are going to see how can we reuse that, the existing specifications, and adding how do we add one value to this. So Abdul, you're asking how to start from scratch, which tools are created to create it, Forge, YGs are required. I can not explain now how to start from scratch, but the good news is that we have a webinar that explains exactly that, what is an implementation guide, how to do it, how to get started from scratch, and I will try to show it to you in a second. So we have this, copy link address, and in this link you have the tools that you need to set up, the way to do it, all these things like why should we have a logical model first, etc. Please go through these things, the presentation and the slides, and you should have a good thing. Otherwise, as usual, reach out, chat.fhir.org in some other way, and just reach out to me or to any one of us, and we will provide whatever information we can. So so we wanted to do is to add the allergy to wheat. This was not in our initial value set, so we need to add something there. And our decision is, do we want to reuse or inherit, or do we want to redo things? And that's what we are going to try to do today. So the food allergy, as I said, it had a logical data model. It had a questionnaire that we are not going to worry too much about it. It has a profile, and it had a value set, food allergies. It also has an example, but we don't care much about this. And the value set for food allergies, it inherited from SNOMED. And I just mentioned it here, because this is actually another way of layering. So we are making a food allergy IG, so a purpose-specific implementation guide based on something that is generic and universal, like SNOMED. So we are always we are always standing on top of the shoulders of the other standards. So in this case, we are taking a bit of SNOMED because when we want to send our information, we want other people to to relate to this, to understand it. So we don't want to make our codes for peanut allergy. We just want to use a SNOMED code for peanut allergy. So this is the SNOMED codes. So our value set is using the SNOMED code system instead of us having to decide to define our own code system for allergens. So that's what we have done. So we were already inheriting in the first implementation guide. So we have this food allergy with these things, and we see, okay, do we want to reuse logical model? We want to reuse the profile or not? And we want to reuse the terminology, yes or no? In practice, what we are going to do is this thing, and I hope the picture is somewhat clear. That's what I meant when I showed the other picture, the bigger picture. What we are doing here is to say there's a food allergy IG, and then we have it's not easy, it's AZ. I was looking for a fictitious country, and I found out that the best country I could figure out was Atlantis. Sorry, just a fictitious country. And the international ISO code for countries that have for fictitious countries actually is ZZ or ZZ. So let's say I want to make the food allergy for a specific fictitious country, whatever country it is. So what I'm going to do is to say I'm going to sit a layer, and I hope the 3D is kind of explicit here. I'm going to sit a layer on top of the layer that I have here. So I have logical data model, and I'm going to make a logical data model, which is ZZ food allergy, that hopefully relates to or inherits, that's the question, to my logical model on the lower level. I'm going to make a profile, which is ZZ food allergy, that is hopefully inheriting, if possible, from the food allergy that I had on my lower base. So I'm just adding constraints. Same thing with the questionnaire if I had to, or if I wanted to, and the value set if I wanted to. So that's what we are doing. When we do profiling on different layers, it's pretty much it. And I'm going to show now how it's done in practice. So how do we do that? Actually, Abdul, I think answering a bit your question, not really answering it, but just showing you the steps to make an implementation guide. Let me just share with you. So I have food allergy, and I just call it AZ for Atlantis or ZZ for the profile. That's not it. This was it. Oops, sorry. Do I have this right? I renamed it. Let me see if I have. Sorry, let me just check because I was just changing it a few minutes ago. Let me see, food allergy. I'll just use this one. Let me just check if I did all the right commits. I did. And the history is there. All the commits are there, so that's good. I think it's just the name that I got right, that I did not get right. Maybe I did. Let's see. Let me see. Yeah, okay, so the commits may be fix issue with the that's really strange. So I'm just looking at this. So I'll clean up the story afterwards. I just wanted you to have a clean the story of commits, as you can see, which I have here, like initial commit, setup, implementation guide, and then add an intro page. I'm going to follow these steps now. I thought they would be plotted here, but there's some redirection here that I'm not understanding. Anyway, so what we do, we have an implementation guide. We make an implementation guide from scratch. If you go look into the other webinar, you'll see how that's done. It adds a lot of content. We don't have to worry about that. And then we set up the implementation guide by having the by adding the title and the scope, etc. So we just define the name of the implementation guide and the definition, the description of implementation guide, the version, etc. And we add a small README file. That's not really difficult. So what we are doing, nothing really overly complicated. I'm just opening the code in my window now. And then what do we do? So we say we want to add. So we have now 2 implementation guides. And the first thing I'm going to do is to say I'm going to add, sorry, where is it? I need to check where it is. Let me check. Sorry. Yeah, and I'm going to add a dependency. So this is the technically more interesting thing about the packages. That's why I mentioned the packages before. So if I have my food allergy webinar, and if I have my food allergy webinar AZ, or which should actually be called AZ, just fix that for you. So if I have my food allergy webinar the second one, and let's say I want to build this up so that it inherits the content from this one. What I have to do is the first thing I have to make sure that the first webinar is published somewhere. So if you go to build.fire.org, where this is, that's what I was showing. It's published, and it's published in the official HL7 implementation guide continuous build. So it's publicly available, and this means that the package is out there, and I can refer to that package. I will show, especially if you're more of a developer, you'll see this very quickly. But it's important when you inherit something that you know of course. And typically that means you inherit published packages or published implementation guides. If something is only working on your machine, you can still inherit based on this. You can make an implementation guide layer for national level, and then you can make another layer on top of this on your machine, because your machine knows what it has been. It has a package cache. But if you want to collaborate with colleagues, or if you want to use someone else's specifications, then of course the lower levels have to be published somewhere so that your upper levels can depend on this. And how to do that? It's very simple. This is the trick here. I hope you can see my screen. I don't know if I can zoom in. I will show you just this on the code. So there is basically a very simple thing that what you have to do is, and this is commented out, doesn't matter. So what we have to do is to say, I want my new implementation guide to depend on my OpenHIE FHIR food allergy. So this is my food allergy, and this is exactly the one that I published before. So this is my food allergy webinar. And if I go here, just for you to see how technically this works, the implementation guide has a package ID, which I'm not finding, package ID. Yeah, so you see, this is the package ID. So the moment that you run the publication, it will be published, so you can reuse it. So very quickly, just to go through these things. Yeah, so we are almost at time. So what you do here is very simple. You point to the package and say, I want to depend on this. So from now on, whatever you do, you can reuse the content. And first thing that you have to do, and I'll show you the code that's been changing. I added an intro page that doesn't change really anything. And then I'm going to create a new value set. And since my value set is different from the value sets that we had before, so I want to add the wheat added to my value set. What I do is I just copy the old specification, the old value set. So in the lower specification, I copy to myself. So I'm not, in this case, I'm not inheriting or reusing. I'm just copying. This is one of the choices. So in this case, I decided not to reuse. I could reuse. It's possible to make a value set based on another value set, but just for demonstrating this, I decided to say I decided to stay on the not reusing part. So I just copied the specification. It's not that much to copy, and maybe I want to, in my country, to remove fish and shellfish and just keep fish anyway. So I'm just going to, as a hypothesis, I'm going to use I'm just going to copy the content and not reuse it. That's one thing. So first thing that I do is to create one implementation guide. Then I inherit from the other package, and then I started thinking, okay, what about the value sets? Well, the value set, that's the thing that I really care about. I want to add wheat. Do I add wheat to the existing value set, or do I just create a value set on the side? For now, I decided, or at this moment, I decided to say I'm going to recreate it. Once I recreate, I have to maintain it forever until the specification dies out. But that's the main consequence. Same thing to the logical model. The logical model has a few tricks that you cannot really inherit easily. So I'm just going back to the presentation also to guide us through there. All these assumptions are documented here. So the thing that I mentioned about the packages, you just add this. Then I add a intro page and the value set. As I mentioned, the logical models. We want to add a logical model. If I look at this logical model that I had in the specification, I see that the allergen doesn't say anything about which codes it uses. And I want it to be clear on the logical model which codes I'm using. So I'm going to make a new logical model, which is actually very similar, exactly the same as the other one, but with an additional constraint, which is the allergen has to be from my value set that I just added. So if you compare this value, so the model that I have here with the model that I had in the lower implementation guide, this line is the only difference. Everything else is the same. I just added this line to say allergen is from food allergy ZZVS, which is the value set, and it's extensible. Very important. I can only do that because my profile doesn't say it has to be this value set. My profile says it can be this value set or an extensible, or the value set binding is extensible. So we have the so we just made the model. Now the most important part, the really fundamental part, and I know that we are almost at time, but it's the profile, and this is it. The profiles, it's once we have this inheritance thing, the profile gets extremely easy. So this is the one that I inherited. So I did not inherit the value set. I did not inherit the logical model, so I copied it. So there was a lot of content, but the only thing that I want to have in my new implementation guide, in my national implementation guide, is to say it's simply a new value set. So what do? I create the value set, and I just change one constraint here, which is everything else is the same. So my profile is food allergy ZZ. The parent is food allergy. So I say I'm not basing this on allergy intolerance from FHIR. I'm basing this on the food allergy that comes with the other package that I just depend on. I keep the title, I keep the description, and I say the code has to be from that value set. And I would just like to share this, how this works. So I guess I can show this. So this is my food allergy AZ, so the second one, and you can see there that I have my logical model, as I should, my profile, and my value sets. So my value set, it's there, it comes with the wheat, it's redefined. My logical model, it's there, and it has, the allergen has a binding. There's a bit of a bug here, but the allergy has now a binding. And the most important thing now that I have is this profile. So with one line of text, I could inherit all the profiles for food allergy, and I just say in this specification, I say my allergy intolerance is the same as food allergy, but with an additional constraint, which is the code comes from these food allergies, which is the value set that I have. If I go to the snapshot, it's exactly the same thing as the other, but the allergen is in my it's with this value set. So it really comes down to this. Let me see how we are with the slides. I think everything is covered. Yeah, so the most important thing is the profile, but I just wanted to make it clear that we just, because of inheriting, we don't need to rethink anything. We just say, well, the code is no longer coming from value set number 1, it now comes from value set number 2. And this is the power of inheriting. So I just created a profile. The logical model was optional. The value set was important, so I added it. And my codes, my profile is just one line of text. With that, and looking at time, that was it. I don't know if you have any discussions while I show this. If you want to reach out, any topics, any things that you think I missed, any things that are important. These repositories will be there, and you can see the steps to get there to implement, and at any time reach out. Any questions, any remarks, any topics?
You could inherit from lots of different sources, right? So you could inherit wheat from ZZ, you could inherit, I don't know, shellfish from YY. Yeah. Exactly.
So you can say, if I want to make an HIV implementation guide, you can say, I'm going to, so an HIV case reporting, I'm going to import the data dictionary from the HIV stuff, and I'm going to import the architecture from the transactions from the case reporting stuff. So you can combine those. It's not uncommon at all that you combine everything. It pretty much what it does is that you say, I want to depend on all these things, and what the tooling says is, okay, let me get all of these to our pool of working artifacts. And from now on, you can use any of those that are your availability.
And then what happens if someone changes the source you're inheriting from? Do you get some sort of warning? Does it maintain the point at which you inherited it? Does it update automatically?
Good point. No, so when you run the publication, it gets the packages as they are at that moment. That's why you can always look at the version. So you say, I want to stick to version whatever. So you see, in this case, I want to use the current version. So whatever's on the server, I want to use it. But if you say, I want to fix this to version 0.1 or version 1, then as long as version 1 is there, then you use it exactly as you are. And the only time this changes is when you republish your work. So if you republish your work, so if you make a change, if you want to say, okay, I made a change, I want to republish this, at that time, it takes the snapshot of those packages and those versions that you use, like the current one or any fixed versions, and then it repeats the whole process. So if something changes upstream, you can control which version do you want to stick to, like any package dependency, I guess, or you can say use the latest. And fear not, if something is incompatible, if something became mandatory that you're not ready for, the publisher will let you know that there's an error now because this thing is now mandatory and you don't have, or your profile does not support it, something like this. Good questions though. Anything else? Okay, so if not, the easiest thing, and if questions can come at any time, just reach out, chat.fire.org, community.fire.org. Chat.fire.org is more immediate. Join a FHIR event, but please at any time, there's some very interesting discussions on chat.fire.org. So how can you test an IG locally? Sharif, nice questions. How can you test an IG locally? That's part, so Sharif, please look at the implementation guide link that I sent just now. So I think it should allow you it tells you how to build locally, which I think it's what you mean by testing. If not, then it's a different discussion. Reach out, chat.fire.org. Kevin, you have dependency conflict resolution tools. Not that I know of. I think you just work on your workbench with lots of dependencies, and if one package that you're depending has a conflict with another package that you're depending, it will explode in your face anyway. So we'll be very much aware of that. So that's pretty much the straightforward answer that I can give to you. You'll never be alone when it fails. It will be very clear for you, and you can always reach out. Yeah, and yeah, thank you, Brenda. There's always a fireside chat. We have a very open discussion about anything that you want to talk about. I will be there for any of these things. So actually, very good questions, and I'm now regretting that I spent a lot of time in the boring part. Yeah, join us for a fireside chat, and we can talk about these things, or reach out on chat.fire.org.